So the continuous has 3 requirements. Now the exists only warrant like this, right? Only, yeah. Only warrant like this, right? Because that's exists, but the FA also defined. But is this continuous? No. So you don't want to ride a roller coaster has that, right? It's not connected. So what's the third condition? Limit x what? Approach to a of f of x equal to f of a. So the third condition is basically saying this gonna move up here, and now it's continuous because the hole fill in the open gap, right? Is this okay?
What's the first thing next to the if the limit? Oh, limit exists. Okay, thank you.
Did I say be fine? Define. Be fine. Okay, so the last one, what was the differentiable?
Is it that the limit of f prime of x approaching a from both sides is equal?
Yep. So this one's differentiable. Differentiable, and then slope on each side, slope equal to each other, right? Equal to each other. From left and left and right. So be limits as x approach to a from the left of f prime of x must equal to limit x approach to a from the right of f prime of x. So the slope had to equal to each other. Okay. So in this case, it'll be like a roller coaster is like this, right? Like slope on the left and right are equal to each other. Well, they still have small changes, but that small change is so infinitesimally small, so it's not gonna have issues. Okay, do you guys remember 3 situations it's not differentiable? Can you tell me what's the 3 situations not differentiable? Wesley? Horizontal asymptote, no, they are differentiable. Okay, so vertical asymptote, but yes. Okay, what is that called? Sharp turn. You can call it a sharp turn. Anything else? There are 3 situations when the function is not differentiable. What's the third situation? So the first situation is that Wesley says is the vertical asymptote, but I want to be more generalized. I'm gonna say it's when the function is not continuous, right? Not continuous at particular point, which is it could be something like vertical asymptote, which is also known as the what? The non-removable discontinuity. And the second one is what? The hole, which is also known as non-continuous. So it's actually there was 2 situations in non-continuous. The second situation is a sharp turn. Well, which kind of sharp turn? So f of x equal to absolute value of x. Yes, that's not differentiable. There's also another one. What will be another situation as a sharp turn? It could be, yes, it could be piecewise. But something called a cusp. Right, cusp. 2 over third, even over odd power. Anytime you have even over odd power is a cusp. None of those are differentiable at x equal to 0. So we call it sharp turn. A sharp turn. But it's more likely absolute value is going to have a sharp turn from a positive 1 slope to negative 1 slope. From x to the negative 2/3 or 2/3, it's going to have. This one's also sharp. This one is a cusp. And the third condition, do you guys remember the third condition where it's not differentiable? You can have not differentiable in the situation. What will be the third situation is not differentiable? Usually people forget about this one.
Is it where it's vertical, vertical asymptote? I mean, yes.
We already meant
vertical tangent. That's what I meant.
vertical tangent. Thank you. Now this one usually people forget, but f of x equal to cube root of x. This are vertical tangent because the graph's gonna be something like this. So at this point, it's not differentiable because the slope over there is infinite. So in this case, we're gonna say infinite slope does not exist. So it becomes straight line, right? Think about if you take a derivative at x to the 1/3, that's gonna be 1/3 x to the negative 2/3. Now if I go to 0, in this case, it's gonna be positive infinity on the right hand side, negative infinity on the left hand side. So it's gonna be not differentiable at 0. So that is also another one, vertical tangent. Now, is a vertical tangent applied to both? Yeah. So vertical tangent is actually this one and this one. Both of them are vertical tangent. Does sine of x has a vertical tangent or no?
No.
No, because the line that crossing the x-axis is more slanted. It's not vertical. Okay, so sine of x is not vertical tangent. X to the 1/3 is. Am I confusing you? Jing? You got it? Okay, vertical tangent because slope is going to be infinite. Imagine if I plug in 0 here. We can't even plug in 0 because it's on the denominator. But not only that, if it's a denominator, if we can plug in 0, we got to use approach limit. So we're going to plug in, I say, 0.1 in there. We're going to find out it's positive infinity. If we plug in negative 0.1, that's going to be also positive infinity. So therefore is infinity is the slope. Slope is not defined. So vertical tangent is not defined. So why do we talk about differentiability before we talk about mean value theorem? Why do you think we need to talk about that? Do you guys remember what's mean value theorem? Or Rolle's value theorem? Yes? Okay. So can somebody tell me what's Rolle's value theorem? Nathan knows, but I don't want to ask Nathan. Nathan's like, I remember this. Good. I need the rest of you guys to see if you guys remember. What's Rolle's value theorem? Jordan?
Isn't it the same thing as MVT, but f of b equals f of a?
That'll be one of the conditions, yes. So the first condition is, it's not f of b equal to f of a, but first condition has to be what? It's continuous. F of x is continuous between a to b. The second, f of x must be what? Differentiable. There we go, differentiable. That's parenthesis, yeah, because the endpoint is not differentiable. Oh yeah, I did forget about it. The fourth one is usually people forget is endpoints. I didn't mention that in pre-calc. Okay, thank you, Ethan. I can't number. So the third one is f of a equal to f of b. So what's the result of Rolle's theorem? Vincent, do you know what's the result of Rolle's theorem? AB Calc tutor, come on. I bet Jordan knows. Jordan, do you know? Almost.
Oh, it gives you the average slope, right? No, that's
No.
no.
No, what's the Rolle's value theorem? Aiden? Good. f prime of x equal to 0. F prime of c is equal to 0. Because if you have a same point, right? A and B,
Oh, and that, yeah.
right?
Yeah.
You have to, if it's straight line, I have f prime of x, f prime c is 0. Even the simplest differentiable and continuous function could be a straight line. But you know that not all functions are going to be straight line. But they have to have a same output at A and B. Had to be the same. If they are the same, somehow in the middle, the slope has to be somewhere in here. Slope is going to be equal to 0. Now, you could have something like this, right? You could also have something like this. You could have at least one C. You could have at least one C. So, at least one C where f prime C is equal to 0, which is kind of makes sense. You could have something like this. That's a C, right? You could have something like this. This is 2 C's, right? So you could have 2 C's where slope is equal, you have horizontal tangent. And I don't know who mentioned horizontal tangent, and Aiden. So Aiden mentioned horizontal tangent as another way to say f prime of x equal to 0. It's not another way to say f prime of x equal to undefined, however, because f prime of x equal to undefined is actually vertical tangent rather than horizontal tangent. Okay, vertical tangent. Which is, that's why Rolle's value theorem work. And that why it's a vertical tangent doesn't work, because if you have A and B like this, if you have both the same point, you could have something like this, which is, that's not f prime of x equal to 0. Right? It's actually f prime of x equal to undefined. So this is very crucial, Rolle's theorem. The best way to memorize this is this O right here. This is f prime of x equal to 0, and that's the easiest way to remember horizontal tangent. Versus f prime of x equal to 0. The rules, the O in the middle, is kind of represents for that. Now, who invent? This will be a good quizable question, right? Who invent mean value theorem? Somebody on quizable? Anthony?
Yeah, Anthony.
Huh? What? Mean value theorem? He probably had mean value theorem in quizable. It is somebody with L, but it's not El Hopto. It's not Lambus.
It is not John Locke.
Why does everybody say John Locke? I don't understand. What a dumbass.
Kylan, it is not John Locke. Don't you dare.
It's not John Locke. Who's the person in come up with mean value theorem? It's not alignment, no. Lambert who invent calculus. El Hopto who invent El Hopto rule.
Was
What?
it Larry Mean?
Augustine Louis Cucci.
Who the hell?
That's what Siri said.
There's a mathematician named Lagrange.
Lagrange? Like Lagrange?
Oh, Lagrange.
Lagrange. I mentioned that last year, right?
You did. I just could not remember because I was not like. Well, we don't have to remember that kind of thing. I can't wait for the test question to be who invented mean value theorem.
Okay, so Lagrange basically is actually, he says, I told you guys last year, I said Lagrange kind of like copy everything from Rolle's.
Except he made it so that it's equal to the average.
Yeah, so which condition that mean value theorem does not have, where Rolle's value theorem have? F of A equal to F of B. So, what if today I excluding this, right? So remember last year I kind of said like he kind of stole the idea, but he just kind of like tilled the paper a little bit. He tilled the paper a little bit, right? So what if this is not there anymore? Then the f of a does not equal to f of b, so therefore it's going to be like something like this, right? So it's continuous and differentiable, but a is right here, b is right here. Now they don't have to be the same point. They don't have to be the same point. So you kind of tilt the paper a little bit. And you say, hey, I come up with a new theorem. It's called mean value theorem, right? Why that is, though? Well, mean value theorem says the first condition is f of a, well, f of x must be continuous. Like, must be continuous between a to b, but not including the endpoint. Actually, oh yeah, that doesn't including endpoint. B is f of x must be differentiable between a to b. The C is, there's no C. So what is the mean value theorem tells you? Yes, Nathan?
FB minus FA over B minus A equals F prime of C.
Now the C must be within parenthesis A to B, not bracket. You cannot be endpoint. It's something also there here too is A to B as well, because you cannot including endpoint. Endpoint is not differentiable, so it doesn't work. So if you sometimes, especially for computation questions, those of you guys are doing computation, you cannot including the endpoint because sometimes you got two C value, one C is at endpoint. The C point must be excluded if it's on endpoints. So you cannot including the endpoint. Does that make sense?
Yeah.
So make sure if you're doing computation, make sure don't including the endpoints. In the AP exam, sometimes it could happen, but it's only 1 out of 10 times, because if a student can do mean value theorem, it would be hallelujah already. But you know, it's not very a lot of often time they will pay attention to endpoints. But for competition, 99% of the time it's gonna say, hey, they're gonna trick you, and answer will be nota rather than the both answers there. So if both answers you're excluding that both answers, you should choose nota, or you should choose that one answer that is within the boundary, right? So those are things that they can trick you from competitions rather than anything else. So there we go, there's mean value theorem. Okay, now why that is, right? If you think about it, if it's a continuous function, if my easiest function is a straight line, guess what? The slope of this and this are equal to if it's a straight line. Does that make sense? Because if I take a slope of this and slope of this is still same thing. They are equal to each other. But the problem is usually you're not gonna get an equation like that. You might get an equation like something like this, right? So that you have a secant line, which is the f of b minus f of a over b minus a. But at the same time, you have a purple line here that roughly exactly the same slope. So this is the C1 and this is the C2. So you could have that. Am I going too fast? How much time I have? Should I cover more? Don't lie to me. You know I
When does fifth period end?
you know I can teach in 2 minutes.
We have 22 minutes. Yeah, we're fine.
Okay, so
3 more left.
Rolle's value theorem, mean value theorem. The next one is pretty easy. It's increasing and decreasing. How do I know the function's increasing? Test for increasing versus decreasing. How do I test for increasing and decreasing?
If f prime of x is positive or negative.
Yep. f prime of x is greater than 0, f of x is increasing. Which just kind of makes sense because you have positive slope. And also that f prime of x is less than 0, f of x is decreasing. What happened if f prime of x is equal to 0?
It's stable. It's neither increasing or decreasing.
Constant.
Constant. That's the word. Thank you.
So that's test for increasing, decreasing. This is very, very easy, right? Hopefully. Raphael, you go okay? No? Good? Good shit?
Should now be back from A1.
Okay, so what's a first derivative test? Do you guys know what's the first derivative test? No. What's the first derivative test? Nobody know what's first derivative test?
You mean the number line test where you
Maddie, what? To find maximum. So how do you find a maximum? How do you says how do you on AP exam, if there is a maximum, how you supposed to word it in a correct way in order to get a point? So this is called a first derivative test. The first derivative test is very, very essential. Can you tell me what the first derivative test is, Ethan?
if f prime of c goes from positive to negative, it is a maximum, and if f prime of c is negative to positive, it's a minimum.
Yes. So the first derivative test and the second derivative test is all telling you where is the relative max and min, but just two different ways, right? Two different ways. So first derivative test is f prime of x change from positive to negative. Now on AP exam, you had to write it like this in order to get a point. At a C, then F have relative max at C comma F of C. So that's the first derivative test. Second, same thing, but the other way around. Change from negative to positive at C. Then F has relative min at C comma F of C. And you must do a number line test. The number line test is not first derivative test, however, but show with number line test. But AP exam doesn't take your number line test. Remember, if you draw a number line test, the AP exam doesn't count that. AP exam is gonna say you have to write down a changing from positive to negative in order to have a relative max. From negative to positive in order to a relative min. You cannot just do a number line test, but you use a number line test to guide you to tell you where's the f prime max. Yeah, so the first derivative test. Okay, so let me give you a question. Mean value theorem, you guys are gonna have a worksheet, but I'm gonna give you a question here. F of x is equal to x squared minus 4 to the 2/3. Guess what? This is even over odd power, right?
So, yeah, all of that makes sense.
I only need you to find the first derivative test. And you're gonna tell me, are they increasing, decreasing, maximum, minimum? You must do a number line test in here. The number line test in this one is a little bit more difficult. So, wait, this question may be too hard for you guys. Is this too hard for you guys? No? Okay, if you want an easier question, it'll be this one. Sorry, I'm not like, actually, I sound like kind of insulting. But it wasn't intended to be, sorry. Because I just jumped straight to there because some people didn't take the BC, AB. So I start with the easy one. If I do, I will start with the easy one. This is the hard one. So if you can do the hard one, good. If you can do the easy one, this is the easy one. Huh? First derivative test told me where's relative min and towards relative max, and how do you do it? I think we finished 2 sections today, which is good. We don't want to do more. Well, we can do more if you want. We like speed run through this. Last year we take like a week. We're doing 1 day. It's pretty good. The hard one's kind of hard. The easy one's relative easy. I'm gonna airdrop you the homework first. I'm gonna drop you the first worksheet, speak value theorem. If you want to turn on your airdrop, I can airdrop to you. You done this last year, so it's just a review. I will give you rules value theorem, and I'll give you first derivative. Do you guys join the AP classroom yet?
No.
Can you do that shit now?
That's why.
You don't want to get into the end of the year and you don't have AP then. Anybody didn't do it? Can you do it right now if you didn't do it? Raphael, did you do it? Kushif, did you do it? For the second one? For the hard one?
The first one was not bad. It's not that bad. You are going. You're. Don't get paper complex.
Maddie, why you decline me?
Not like equals to the
Okay. I want to keep on sending to you. I'll send you like 5 different PDFs.
What? Did you ever actually explain how to do the number line test to Raphael and Jean?
Okay, so that's what I'm going to explain.
Wow, that's crazy.
How does spell rule? That's the second worksheet is Ross value theorem. So I'm gonna send it to you right now.
We have to do both of these tonight.
There's another one coming.
to do 3 of these tonight.
It's easy.
Mr. Yang, I have work tonight.
Light work.
What? How many works?
3.
This is all something you've done last year.
You lost a point already.
Okay, I'll give you 2 today. I'll give you 2 tomorrow. We average it up. Is that good?
Yeah, thank you.
Or should I give you all 4? I'll give you 3. I'll give you 3. I'll give you 3, but you only need to finish 2. Mean value theorem and Rolle's value theorem.
What's this? I think he's not the wrong person.
Oh,
What do you know what I'm talking about?
what are you doing? What are you talking about, Leslie?
Sigma doesn't exist in this class.
It's right here.
Sigma does not exist. Okay, I'm gonna go over the other 2. I'll send you the next one. I sent you 2 already, so that's good start. So those of you guys don't know how to do it, I'll show you how to do a number line test. If I take a derivative of this, it's gonna be 3x squared, right? Minus 3x, I think. So I will factor out this, which is 3x times x minus 1. Raphael, are we okay here? We're finding the zeros and we're finding the ones, so it's going to be 3x and x minus 1. We're going to have to plug in negative numbers, so that's going to be negative, positive, positive. If I plug in negative value, it's going to be negative, negative, positive, so it's positive, negative, positive. So I'm going to write down on the bottom this increasing, decreasing, increasing. So x equal to 0 is a relative max. Is that okay? Raphael, do you understand?
Oh, there's a bunch of stuff on the screen.
X equal to 1. I'm sorry. My fault. X equal to 1 is going to be relative min. Now, if I want to find out value, the maximum value, I have to plug in the original function. It will be 0, 0. That's going to be the max value. It's going to be the 0. If I plug in 1, what am I going to get? 1 comma what? Negative 1/2? Is that right?
Yeah.
It's going to be a relative, it's going to be a minimum value. Minimum value is going to be negative 1/2. So I could ask you minimum value or maximum value. In here, I'm going to take a derivative, so which is push shift, do you understand?
Yeah.
Okay. I'm going to take a derivative of this, so it'll be 2, 3, x squared minus 4 to the negative 1/3, and that's 2x. So I hear you are going to get 3 critical points. What are they? 0. What else? Did you get 3, Aiden? Negative 2 and 2. You must have including all of them. So I hear 2 over 3 does not contribute a sign, but x squared minus 4 to the negative 1/3 does. So this one's going to give you a negative sign, positive sign, positive sign. Is that okay? Wait, hold on a second. That doesn't make sense. That's something wrong. Sorry. It's going to be... This one is going to be positive. This one's negative, negative, positive. Yeah, thank you. The reason why is that way because if you plug in negative 3 square, that's mean 9 minus 4 is 1/3. Now, if you plug in something less than that, it's going to give you a negative value to the negative 1/3. It's going to give you negative values. Jing, do you understand? Now, last one's going to be negative, negative, positive, positive. So it's positive, negative, positive, negative. So at negative 2 is a relative min. And this is a relative max. And, oh, sorry, not min, sorry. This is a max. Because, and you can plug in there, so it'd be negative 2, 0. And 2, 0 is going to be relative max. Yeah, max. Min, sorry. Min, can spell. Okay, and 0, what is a 0? To the, I don't know what is that value is, but it's going to be negative 4 to the 2/3 power. I don't know what that value is. It's going to be a relative max. And that's, there you go. Okay, so you can start with those two worksheets. And tomorrow we're going to talk about decreasing and second derivative tests.
Yeah, what would the constant like
Huh?
for the two? What would the constant like for the?
Oh, by the way, you guys, we already talked about, okay, so this one's going to be what it look like. X squared minus 4 to the, which power?
So it's gonna have a 2/3.
2/3, right? Last year I showed you the heart, right?
Yeah.
So I have a boy ask a girl out. It's extra 2/3 power. Would you go out with this guy? I thought it's kind of cute, but that's me. I would go out with this girl. And then I would probably, in high school, I'll probably go out with any girl.
I like
But there's an extra 2/3 power. It's from the cusp on the top of the heart. And the other one is circular, so square root of r squared minus x squared is circular. So it's kind of restrict that cusp into a circular, so it will actually make it to the heart. And the sign just make it a inside a restriction that it's gonna give you that value. So which is, I thought it's pretty cool. All right, get to work. What'd you say?
Well, because it doesn't say you need to find. You need to find where.
Yeah, this should be. Yeah, I think you get the prize. I don't know, can somebody post on group chat?
Stop.
Yeah, one's been rolled by there and one's a
Which I kind of have some.
I might have to stop your eye with my phone.
Please read your students will be loved. Remember,
Again, I don't think there's nothing. What's the matter with that?
Literally
Yeah, I think that day I almost passed out, but I need to make sure I get on. I go to the morning. For a kid. Broccoli. I look up best broccoli. Next time I bring some. Wait, you eat like a non-cooked broccoli or what? How do you cook your broccoli?
it depends on how much time I have. You just put pepper and garlic. And you don't have to do it fast.
Pepper and garlic? Do you use just
I air fry it.
air fry it?
Because it gets crispy.
That's actually interesting. I don't do air fry. Okay. Okay, try that.
Are your kids vegetarian too?
I'm vegetarian. I'm vegetarian because I'm a Buddhist. Not every Buddhist is a vegetarian in Asia.
I'm supposed to be vegetarian.
Hinduism some are vegetarian. But in China, like there was an emperor. He was a Buddhist. So and he said, well, if you're compassionate to, like, you should practice compassion. Like if you practice compassion, then you should practice compassion toward animals as well. So he says, now like people should be vegetarian. But not all Buddhists are vegetarian. In Japan, it's not. In Thailand, it's not. And some India is not. Some India are. So not every part is vegetarian. But
Yeah, for us it's like because like cows give you like they give you milk, they give you things.
that's sacred.
Yeah, they give you stuff that
What?
to live. So why?
So what do you look about cow? Like over chicken?
I mean, you're not supposed to eat meat, but
Yeah, but not logical. Like chicken. The chicken's not.
exactly.
Why is chicken sick? Why is cow sacred and the chicken's not sacred?
Cows are better than chickens.
Oh, that's true. I mean, I guess I
You're not. But you're not supposed to eat like cow. Like my dad, he doesn't eat cow, but where I'm from in India, like my culture and stuff, you're not.
you think it's
Maybe I'm just worried about getting the cow. Okay, that. And then
No, it says it's slow people show.
Yeah, sorry.
also 2AX.
I wasn't originally planning to move on this weekend maybe. They just hit me that it's my last. Yeah.
Which color do you want to swim? Can you recorder come up to you?
I have time 3D too. I'm like at the cusp of doing it. Like if the rest of my season goes